Geometric sequence. All right, let's do geometric sequences and series. Like this with Keanu Reeves, if your algebra teachers are really pirates. And they're using us to find X so they can find the treasure. Oh, okay. So we've got a geometric sequence. Remember before we were learning about arithmetic, and arithmetic had a pattern. The pattern was you're always adding the same number. Remember, you can be adding a negative, right? The common difference could be a negative number. Well, geometric means you're always multiplying by the same number. That's the pattern here. We call this ratio, we call this the common ratio R. So that's going to be the important part right here. Okay, we have this common ratio R. And don't forget, we also still have U1 is still the first term. So that terminology is still the same. So that stuff holds true. So let's see if we can figure this out. So we have this pattern 2, 4, 8, 16. Just want to show you it's not arithmetic. If it was arithmetic, you'd always be adding the same number. You'd think, oh, to get from 2 to 4, I add 2, right? No problem. But then if you add 2 to 4, you get 6. Oops, not 8. And you add 2 to that, you get 10, not 16. So it's not arithmetic. In fact, it's geometric. It means you're always multiplying by the same number. That's the key thing here. And geometric is this, okay? You're always multiplying by the same number. Okay? So in this case, that same number you always multiply, that's called R. Now, how do you actually determine that? In this case right here, I mean, sometimes it's obvious, you can just look at it, but sometimes it's not. So I'm going to show you this little trick. Remember, like before with arithmetic, if you do your second term and divide it this time. So before we were subtracting, now we're going to divide. So we're going to do 4 over 2. What do we get? In other words, second term divided by the first term. We get answer of 2. What about the third term divided by the second term? We get 8 over 4. That's also 2. Turns out 16 over 8 is also 2. So in this case right here, R equals 2. That's how we're going to define this one. Don't forget U1 then is the first term, so in this case it's 2. Now we can fully define this geometric sequence. How about this example right here? We'll do it in a different color maybe. Purple. This one right here. Let's try to figure this out. See if it's arithmetic. It's not, because you'd have to subtract by the same number, and here you're subtracting 6, here you're subtracting 2 to get that, so that doesn't work. So let's see if it's geometric. Probably is, since I told you it was, right? But let's double check. What we do is, again, we divide the second number by the first number. So we do 9 over 27. What does that give us? Well, it's a little bit harder, but they both divide by 9. 9 divided by 9 is 1. 27 over 9 is 3. Let's try this one. Let's do the third number divided by the second number. So 3 over 9. They both divide by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. Turns out 1 over 3, well, duh, it's just 1 over 3. Do you notice then there's a common number here? R equals 1/3. So although you might think you're always dividing by 3, you're technically multiplying by 1 over 3. That's the way we get around it. So we call R can be a fraction. It can be positive or negative. That just means you multiply by a negative number. That means you're going to switch these signs. If it was minus 1/3, let's say, it would go 27 minus 9, then plus 3, then minus 1. So that could be the case. U1 is the first term, so in this case it's 27. So just try to show you how we can define some of these bad boys here. So that's how we do those. Now let's go a little bit deeper then. We've got an equation for the nth term of a geometric sequence. You don't have to look it up. You don't have to memorize it. You do look it up. So this is in your formula booklet. So don't forget what these different things are. Remember, R is your common ratio. That's your number you're always multiplying by. Okay, so common ratio. And don't forget, U1 is still your first term. And if you want the nth term, as they call it, the 5th term, the 10th term, the 20th term, the 5 billionth term, you just make your n 5 billion, make your n 5 billion, and away you go. And I could not stress this enough. This thing right here, it's the biggest mistake people make on these. Don't just multiply U1 and R. In other words, you might be tempted because you see this number times this number, think, oh, I just multiply those two. But no, you got to remember your order of operations. Remember PEMDAS, maybe you've called it that, right? So PEMG, so parentheses. Let's see here. So parentheses, exponents, multiply, divide, addition, subtraction. Parentheses come first, there's no parentheses, but then next comes exponents. Exponents come before multiplying. So in other words, first you have to figure out r to the power of whatever. You do that first, then you multiply that answer by u1. Do not multiply u1 times r directly if there's an exponent going on here. You got to deal with the exponent. It is by far the biggest mistake people make when actually calculating something. So please don't be the person to make that mistake, okay? Watch out. So here we have a question. What's the 10th term in this sequence? Well, first we've got to determine if it's geometric. It probably is. Let's see. Well, let's see first if it's arithmetic. I always just check arithmetic first if you're not told. And we're not told here. Of course, it's in the video under geometric, so you're smart enough to know it's probably geometric. But just to double check, right? 2 plus 2 gives you 4. 4 plus 2, though, gives you 6. Oh, so it can't be arithmetic. Must be geometric. Let's try it out again. So second term divided by the first term, that gives you 2. Third term divided by the second term also gives you 2. 16 over 8 also gives you 2. So from this, we know that r equals 2. We also know that the first term is 2. Hey, that's kind of nice. They're both 2. So remember, if you're going to do this, show the examiner you know what you're doing. So you can even write this down. It really helps. This way you tell the examiner, hey, I know what I'm doing. I may screw it up, but at least here's the equation I'm going to use. So if we want to do u10, that's the 10th term, fine, u10 equals, it's 2 times 2 to the power of, because remember, u1 is 2, but r is also 2. So u1 is 2, r is 2. N, however, is 10. So 10 minus 1 is 9. And so you just do 2 times 2, right, which is 4. So 4 to the power of 9? No. Why not? Remember what I just told you. Don't multiply those. See, it's right here where people want to make that mistake. They want to multiply the 2 times 2. Don't do that. It's going to be wrong. You have to first do 2 to the power of 9 and then take that answer and multiply it by 2. So let's do that on our trusty calculator. So I get out my calculator. I need to add a calculator. There we go. So here we go. So I'm going to do, I'm just sort of don't know where to put it. Fine. 2 to the power of 9. Enter. So I get some answer here. So 512. I take that 2 to the power of 9 and I multiply that by 2. So this times 2, this is my answer, 1024. Okay, so that's my answer. It's 1024. Just to show you, had you done it the other way, you'd be exactly wrong. Watch, if you had done 2 times 2 first, that would be 4. And 4 to the power of 9 is not the answer. So you see that? So I just wanted to show you that do not make that mistake, because I've done it before. So be careful with your exponents here.